So in this video, we're going to talk about how to create graphs, when to use graphs, and some characteristics of a good graph. First of all, the reason why we use graphs in science is to be able to identify trends. If I were to just give you a whole bunch of numbers, I don't know, pretend I listed like 100 more, it's hard for us to really see what's going on. Graphs give us a good visual of what's going on, gives us a whole picture view. So there are a few characteristics that all good graphs have to have. First things first is you have to have a title. Usually a good title will have what's going to be on the y-axis in relationship to what is on the x-axis. Your title should be descriptive of what your graph actually is. Both your x and your y-axis have to be labeled. And how we do this is your x-axis is always going to be your independent variable. It's going to be what you're changing in the experiment. Your y-axis is going to be your dependent variable. And remember, your dependent variable is what you're measuring. The next biggest thing your graph has to have is correct spacing. What correct spacing means is if I'm telling you that if we're starting at 0, this next line will be 5, 10. If I'm going to go by 5s, I can't all of a sudden be, this one's going to be 12. Because you're telling me that this distance from here is 5, this distance is 5, and then the exact same distance from here to here is only 2. That's a really big problem that most students have. If you're counting by 5s, count by 5 for the whole bottom, the whole x-axis. If you're going by 2s on the y's, continue to go by 2s. Make sure you have correct spacing all the way up. Also, a big point here is make sure when you're creating a graph to use the entire graph. Remember, graphs are supposed to be visual. It doesn't make much sense to make your graph look like that. What you want to do is make sure your graph spreads out through the whole graph. The larger, the better. So there are 3 types of graphs that we use in science. The first one is a pie graph or a pie chart. And pie charts are used when you compare percentages. This is an example of a pie graph because you're comparing parts of a whole and making it out of 100%. Your next type of graph is a line graph. And these are used when there's change over time. The biggest thing here is that when you have time. Time could be hours, years, decades, seconds, anything over time is going to be a line graph. In this particular graph I just added, we're looking at days of the week on our x-axis. Again, that's what we're changing as the independent variable. And on our y-axis is what we're measuring. We're measuring temperature. I just pulled this graph randomly off the internet. Your last graph is going to be a bar graph. And a lot of people normally default to bar graph, and I honestly think it's because it's the easiest graph. A bar graph is used to compare data. Most of the time students struggle with, is it a line graph or is it a bar graph? Always ask yourself, is there time involved? If so, it's a line graph. Am I comparing? If so, it's a bar graph. So let's practice. I give an example here. It says Bob wanted to see how the temperature changed at different heights of the atmosphere, different heights above the ground. So we have to ask ourselves is, what do we need on a good graph? We need our x-axis and we need our y-axis. Your y-axis is the dependent variable. It's what he's measuring. So is Bob measuring the feet or is he measuring the temperature? Bob is actually measuring the temperature. So our temperature will go on our y-axis, and the independent variable, what he's changing the height of the atmosphere. Next, we need a good title. And remember, your title should be using your y and x-axis. Next, all we need to do is figure out our spacing in between the lines, and remember they have to be even. So what I did here is on the x-axis, I went up by tens. I'm aware that there's a space right here and here. It's just very hard to put those numbers on my iPad. So assume that right here is 40 and right here is 60. It's going by 10. How I'm going to label my y-axis is I'm going to go up by 5s. But my numbers aren't very big here, so I'm going to go every other line is 5. So I already have my 5 on there. I'm going to drag my 10, go 2 up, that's going to be 10. Go another 2, could be 15, and another 2, and that'll be 20. Remember, we have to keep our lines equal spacing. Next, you're just ready to plot your points. So what I went ahead and did is I plotted my points, and once I have my points, since it's a graph, we're going to go ahead and connect them.